We will be discussing on appropriate wildcard usage in the predicates as far as the SQL Server queries are concerned. I'm going to use database AdventureWorks GW for this demo. I'm going to create a table called table1 underscore temp, and table1 underscore temp will get its data from a table called table1. What I'm going to do, I'm going to alter table 1 underscore temp and then add a primary key on the column 1. Additionally, I'm going to create a non-cluster index on table1 underscore temp on column 2. I'm going to switch on statistics IO and then going to execute this first query. I'll be enabling the actual execution plan, and I'll be executing this particular query. So if we see here, I'm able to see that we have returned close to 100 rows. And then if I look at the execution plan, what I'm able to see is like we are performing an index seek using index ix underscore test. And what I'm seeing here is like we are estimating close to 101 rows. We are reading close to 100 rows and then returning close to 100 rows. So if we look at the specific data here, the estimated number of rows per execution is 101. Actual number of rows read is close to 100, and we are returning close to 100 rows, which is depicted as actual number of rows for all execution. Now looking at the IO details, what I'm able to see is like we are performing close to 4 logical reads. Let's execute the next query, which basically uses the predicate column 2, and we are selecting column 1 and column 2 from table 1 underscore temp, and the predicate is column 2 like the value Raja, and then we are using the percentage symbol here. So this query is going to return all the rows that starts with the value Raja. So let's execute this query. So we can see that it returns close to 771 rows. And if you look at the execution plan, it is performing an index seek on table 1 underscore temp using the index ix underscore test. And now if I look at the stats here, what I'm seeing is like we are estimating close to 789.3 rows and then reading close to 771 rows and returning 771 rows. So if you see here, the estimated number of rows per execution is 789.3. Actual number of rows for all execution is 771, and actual number of rows read is 771. There is a little overestimate. We are estimating more by close to 18 rows, but as far as the number of rows read and number of rows returned, both are same, and it looks okay. Now let's look at the IO. What I'm able to see is like we are performing close to logical read 7 here. So next query, we are basically selecting column 1 and column 2 from table 1 underscore temp, and the predicate column 2 like percentage Raja percentage. And what we are basically telling is like we are basically telling like bring in all the rows that basically has this value Raja as far as that string is concerned. So for example, it can be for example if you have something like some characters Raja, some characters, then those rows will also come out if you use percentage Raja percentage. So let's execute this query and then let's look at the execution plan. I'm no longer doing an index seek, I'm doing an index scan. And if I hover my mouse on index scan, which is on ix underscore test, what I'm able to see is like I'm estimating close to 1,578 rows, but I'm reading close to 1,18,890 rows. That is, I'm basically reading each and every row on that particular table and then end up returning 1,559 records. Now, looking at the specifics here, what I'm seeing is that the estimated number of rows per execution is 1578, and the actual number of rows read is the whole table, which is 1,18,890, and then I return close to 1,559 rows. And if I look at the IO stats, what I'm basically seeing is like I'm doing logical reads close to 353. So as soon as I started using percentage value percentage, I'm scanning through the whole table, and then I'm basically like returning a handful of rows. So what is happening technically, it is reading each and every row on the table and then coming up with the information. So now what I'm going to do, I'm going to run all these queries side by side, and then we'll compare the results. Now first let's look at the execution plan. First query, I'm performing an index seek. I'm estimating 101 rows, returning 100 rows. Second query, I'm estimating 789 rows and returning 771 rows. Third query, I'm estimating 1,578 rows, reading close to the whole table, all the data in that table, 1,18,890, and then return close to 1,559 rows. Now looking at the IO stats, the first query performs 4 logical reads, second query performs 7 logical reads, and third query is 353. So the thing is like as soon as I check this particular data, what I'm able to see is like there is a huge logical reads as far as the third query is concerned. And the problem right now is like we need to understand if percentage Raja percentage, that is percentage value percentage, is really required. Because if you see here, it is like close to like 80x of reads that we are doing as soon as I start using percentage value percentage. So it all depends on the application requirement. If the data is as such, then the predicate requirement is as such, then there is nothing much we can do. But we just need to ensure like we have data of that sort before using percentage value percentage, because that is going to make your optimizer check each and every row and come up with the data, and SQL Server will not be able to use appropriate statistics. It has to scan through the whole table to get the data. That's it for this video. Thanks for watching. Have a great day. Jai Hind.